However, Vincent Mattelaer is still with us, and we have a number of questions that have come in for him, so I will plunge right in, Vincent, if I may. And the first question is, will 700 bar on-board storage meet mid to long-term requirements of EU heavy-duty long-haul trucking regarding range above 1,000 kilometers? Is there possibly a need to shift to cryogenic storage?
Well, I would like to ask a question to this. In the EU, is it really necessary to go above 1,000 kilometer range? Especially when I hear that in Germany they will have 750 stations, and also the truck drivers cannot drive even this long distance at once. I'm not sure about that. And also, compared to cryogenic, we are, like I already said, we do not oppose liquid hydrogen. So liquid hydrogen is a possibility in the future, for sure, to have also long distance trucking possible. That is my answer.
Thank you very much. Next question. Are you not concerned about the energy density limitations for 700 bar compressed gaseous hydrogen when compared to liquid hydrogen? For example, we already see compressed natural gas trucks struggling with range compared with liquid natural gas trucks.
Okay. Well, that will depend on our customers, on the customer needs. So obviously, when we develop trucks or together with other partners, there will be a certain range connected to it. So it will be the customer decision in the end if he finds this acceptable or not.
Thank you very much. Let's move on to our next question. Is there a need for a communication interface, in particular a reliable communication interface fulfilling SIL and ASIL? And I have learned that ASIL stands for Auto Safety Integration Level. And the questioner adds, so that would not be infrared as described in J2799.
Yeah, that's correct. So that's indeed correct. If we are going towards advanced bidirectional communication, this will have to change. So we will for sure not use the current infrared communication anymore. So a new standard for communication between station and vehicle must be developed. Yeah.
Thank you very much. Next question reads, Hirose-san from Toyota said once, the first million from Toyota will use 70 bar, and then we will see. Now all your road vehicles are indeed developed to be 70 bar. What is your vision for a mid and long term for hydrogen storage and fueling?
We have not yet reached those 1 million fuel cell vehicles. So it will take it still a little bit of time. But as I already said, yes, we have an open mind. It's not that we want to object against any type of storages. So we are looking into all kinds of storages, and liquid hydrogen, for example, is also into this. But at this moment, we think 70 megapascal, the stations are existing, the technology is existing, it is already working properly. So we think at this stage, 70 megapascal is a good solution for medium and heavy duty trucks.
Thank you. Next question. Do you think we will ever see LOHC fueling systems on board trucks? Is this something that Toyota has been considering?
If I remember correctly, we had a small look into this, but at this moment we are not looking into this type of technology.
Thank you. Next one. What are the main difficulties in enhancing the refueling speed in the MFHF nozzles?
We are mainly involved, of course, with the development of the receptacle, because that's the part that will be introduced in our vehicles. And there are no specific struggles to improve the receptacle to a mid-flow version. The costs will not be expensive, so it will be quite easy. For the nozzle part, that is obviously being developed by partners who are in the nozzle industry. So I cannot currently not comment on this.
Thank you very much. Next question. Could you please give an overview of the CFD simulations? What are the main questions to be answered, and what are the results so far?
So the CFD simulations, so the modeling itself has not yet started. So they only did the meshing of the CFD. They will soon start with the modeling, and then we will see what the results are of those CFD simulations. But the exact technical details, honestly, I don't know myself. I would have to ask Air Liquide and Engie, who have this information. You can forward me the question if you like, and then we can look at it within the Pride group to answer this specific question about CFD.
Thank you very much for that offer. Let's work in just a couple more if we can. Is it a correct understanding that Toyota and partners are changing the definition for high flow used for H35? High flow is up to 120 grams per second to H70 medium flow, meaning medium flow equals up to 180 grams per second, and high flow up to 300 grams a second.
Yeah, that seems so, because that was the definition for 35 megapascal nozzles. So for 70 megapascal, that's the choice we made for the naming. It can still change in the future, of course, but at this moment we call this the medium flow and the heavy flow nozzle. Yeah. So in that sense, it's a small change of naming for if you compare to 35 megapascal. That's correct.
Thank you very much. And here comes the last one, Vincent Mattelaer, with many thanks for bearing with us. Are there synergies in refueling processes and hardware between gaseous hydrogen, liquid hydrogen, and cryocompressed hydrogen?
I think the question refers to overall or to the stations. Yes, I believe so, because the liquid hydrogen stations can also be used for fueling gaseous hydrogen. And this is already happening in several stations, especially around Munich area, also in United States, where they do have the liquid hydrogen as a storage. So you can use it to dispense, for example, a liquid hydrogen truck, or also a gaseous truck. So I think in that sense, if you look at the hydrogen economy for stations, you can combine both.
Vincent Mattelaer from Toyota, many, many thanks for taking us through both Pride and what you're doing here in the refueling area. We appreciate that very, very much.